Hi everyone, this is Thomas Cullen, and this blog post is the third one I'm doing about 3D printing, and this one's more about the societal and the future impacts that 3D printing is going to have. And the first thing I wanted to discuss is the future of the way 3D printing will happen. And currently 3D printing occurs at the level that humans can view. What I mean by that is that we can see the layers get added on to an object getting 3D printed, but the future of 3D printing is nanoprinting and the printing of nanostructures. And what that means is that 3D printers will be creating objects that are extremely tiny at the molecular level. And this is extremely new because the field of nanotechnology is extremely young, because currently we have nothing that can accurately produce objects at that level and that economically. And I just want to start off by just recently, Korean researchers have recently just been able to produce a nano wall, and what that means is that it is a nanostructure that is a wall, and it's very simple, obviously, but it's very important as like a thought exercise or a proof of concept in that these nanostructures are possible. And the reason why it's a big step forward for 3D printing is that they can go ahead and start making more complex objects and eventually create things such as nanorobots and more complicated processor architecture. And another application of nanoprinting is the printing of extremely tiny lithium-ion batteries. And this is also very important to power these objects at that level. Now, the eventual goal of 3D printing technology is to reach the point by which we can produce literally anything through 3D printing. And the idea is there, even though it's very science fiction currently. The idea of using nanoreplicators, or molecular assemblers as they're called, is an idea that can be used to produce literally anything as long as it can be printed and as long as it's stable enough to be printed. And what that means is basically you can take a nanoreplicator, or otherwise known as a molecular assembler, and it'll take the raw material of atoms and it will connect them to each other, adding and subtracting electrons, creating chemical bonds, and it'll do that chemistry and then connect it to an existing object and then just keep printing layer upon layer of those chemical bonds on top of each other. So eventually you have a stack of molecules all bonded together as an object, and then when you just keep multiplying that and multiplying that, then you have an object completely created out of raw materials, which are just atoms. And this is extremely science fiction, like I said, but it's possible as far as one organization is concerned. There's this one organization called the Open Source Nanoreplicator Initiative, and they're trying to actually create a device that can do this. And it's very far off. I don't expect that happening anytime soon, but the idea is very interesting in that it opens up so many possibilities for the future of production and the future of how humans consume things and how humans relate to the earth and how we relate to matter and how we relate to each other. And it's a whole nother can of worms that I think can be a whole nother video. But I just want to share a Richard Feynman quote, and it says that I'm not afraid to consider the final question as to whether ultimately in the great future we can arrange the atoms in a way we want, the very atoms all the way down. What would happen if we could arrange the atoms one by one the way we want them? And that was a speech he gave at the annual meeting of the American Physical Society in December of 1959. Now, the implications of nanoassembly are huge, and that's a whole nother video to talk about, like I said. And what I want to touch upon is about the importance of molecular assembly and 3D printing in space exploration, for example. Currently, when astronauts in the International Space Station, for example, if they need a tool or they need an object, then it has to be shipped up to them from Earth by a rocket. And that'll take a very long time because they don't just send individual objects up by rocket, they send them in payloads. And if the people on the space station right now had a 3D molecular assembler, then what that would do is that they would allow them to be able to create anything, a tool, an object, even food or a foot if they needed a new one. They wouldn't be able to reattach it, but it can literally create anything. And that's huge because it completely decentralizes the modes of production. You can produce an object and not be on Earth as long as the data is sent to the 3D printer. And that's huge even on Earth because that'll completely disrupt in the way future, that'll completely disrupt the way economies function. And what I was talking about earlier, the group Open Source Nano Replicator Initiative, their goal for that nano replicator is to basically eliminate poverty and to eliminate human scarcity. And that's absolutely mind-blowing because our economic system currently functions off of the notion that we live on an earth of scarcity. There is no abundance of anything. And when you have an abundance of something that can be just replicated on the dot, as long as there are atoms around, then that completely changes the way humans relate to each other, the way we relate to matter, and the way we relate to everything. It's literally everything if you have that sort of dialectic materialism kind of thought. And another thing that I wanted to touch on is the importance of that hyper-customization for the medical field. Like I mentioned earlier, a foot on Earth, or a heart, for example, if you need a new heart, you would currently need to wait for a transplant, or you can get it 3D printed, but even then, a new heart would still need to be grown on top of a 3D printed lattice, a biolattice. But if you have a 3D assembler, then you can literally create a beating heart as long as there's an electrical pulse going to it. You can create one as it stands with a molecular assembler. And that's super theoretical. I'm not saying it's possible. I'm just saying that the idea is there and that is the goal of this organization. And that, like I said, that whole idea is another can of worms that needs to be discussed in another couple blog posts. But a final idea that I wanted to talk about the importance of 3D printing in general, not just nano structures, but Madame Eureka on WordPress, that blog, the writer made a point about the mass collaboration that 3D printing could create currently in our time. If everyone had a 3D printer, for example, then a company coming out with a product or a company testing a product and its ergonomic uses, such as maybe the Apple Watch, they could basically send out the Apple Watch data file to consumers and they would try it on their body. It wouldn't be a functioning one, but it would be a concept and people would comment on it, people would modify it, people would modify the data file, they could collaborate and send it back to Apple or whomever they got it from, and they could create a more fine product without having the market test it out first. They can send people an object to test how they would react to it and to see about the public opinion before producing it. It's sort of like how a company releases a beta of a software before releasing the full version, and they allow the users to test it and to send back bug reports. This is basically sending back bug reports on tangible objects, in that people can spot things that are wrong with it before the company can, and it would really be beneficial for products that are experimental in nature, such as the Apple Watch. But in general, 3D printing is a good thing, but as any tools, it can also be used for nefarious gains, such as the 3D printed receiver, an assault rifle that was recently produced by, I think, an American using a 3D printer it was made out of plastic, and a receiver is basically the bottom portion of an assault rifle where the trigger assembly is that operates the hammer. And it functioned for, I think, one shot before it snapped, but the technology for the material is only going to improve. The plastics are only going to get stronger, and the possibility to produce gun parts that are currently restricted, such as the lower receiver, which either decides if an assault rifle is semi-automatic or fully automatic. If you're only allowed to legally own a semi-automatic rifle, for example, and you 3D print a lower receiver that's fully automatic, then you have a fully automatic rifle, and nobody knows except for you, and that could be pretty bad in some situations. And there's also many other instances where it can be used to 3D printing can be used to hurt people. But I'm an idealist, I guess. I think that the gains of 3D printing and of technology in general outweigh the risks that could be exposed to us. But, I could be wrong. Thank you for listening to me, and I'd just like to conclude this video and to thank you for hearing what I have to say about 3D printing so far.